But sort of the 500, 700 milliseconds that I was talking for how long it took to get the image to the screen is one of the reasons I highly recommend testing mobile on actual mobile devices. So these are timeline recordings across a desktop VM that's running an emulated mobile browser. So this isn't even like native desktop hardware. This is just a single core VM, does normal web performance testing. Running Chrome as an emulated mobile browser, so it loads the mobile page, the mobile content, it looks like the mobile site. It's how, before we had like rich mobile testing, how we used to do a lot of our mobile testing was we used desktop browsers and we'd test the mobile sites with them. And you can see, in this case, Amazon.com, it's really not spending a whole lot of time doing anything. And then down below, we've got everything. The Nexus 5 is a fairly high-end quad-core mobile device. Moto G is a lower end, but it's still a quad-core mobile phone. And then the Moto E is a dual-core. It's a fairly good representative entry level. I don't have any, but from what I understand, like some of the Android devices in Africa, for example, are even single core. So they're even slower than the Moto E. So depending on what you're targeting. But you can see just sort of by the density of the stuff going on, the amount of time it takes, and in all of these cases, it's loading the same site, the same JavaScript. The amount of time it takes to actually parse and execute the JavaScript is non-existent in desktop. On the Nexus 5, a little slower, not too bad. Once you get to the Moto G, it's spending an awful lot of time just parsing and executing the JavaScript. And then by the time you get to the Moto E, it's interesting that even doing the layout, the GPU drawing and that kind of stuff, the painting of the images is really expensive. So make sure you're doing your testing on an actual mobile device if you want to know what the actual mobile user experience is, because they make a huge difference. This is a Google search result. So we all think of the Google results page as highly optimized, right? One of the things, so in this case, it's a search for flowers. The search results have a few images in them. The images are data URIs that are injected by JavaScript. Works great on desktop. You can tell as you start going to the lower end mobile devices, this is the point where it actually does the code that takes those data URIs and injects them into the image tags. And it's spending, down here on the Moto E, that's almost 3/4 of a second just to parse and run the JavaScript for displaying the images. So these are not insignificant. It used to be that resource fetching on the network was all you had to worry about. JavaScript was effectively a no-op unless you were doing something really painful, like in an inner loop, constantly manipulating the DOM or something like that. With mobile, all things that are old are new again. You actually have to pay attention to what you're doing in script. Sometimes, even if it looks like it might be a little slower, using native browser support and just letting the browser do stuff versus trying to be fancy in JavaScript may be the way to go. And so this is the Guardian page where they've got a whole bunch of stuff going on. And I think, so you can see like in the desktop VM again, it's still almost doing nothing. There's a block, 200 milliseconds of JavaScript that it's busy doing stuff. The painting, the layout, all that kind of stuff is non-existent. Nexus 5, also still pretty fast. Moto G, you're starting to get chunky. Right around the onload event, it's, what is that, 2 seconds. So the main thread is blocked for 2 seconds executing JavaScript and doing some layout. That's where, the page isn't responding to what the user wants to do based on what they just loaded. And you go down into the Moto E and wow, right? I mean, I'm hoping, and I think I need to do some more drill down. I think this might be a progressive JPEG. So I've been a huge proponent for progressive JPEGs. Display more of the image sooner for the users. Although if it ends up doing that to a Moto E mobile device because it has to keep re-rendering the image and keep re-displaying it, maybe it's worth looking at again. But again, that needs more testing. That's the kind of thing that you want to make sure you are testing on real live devices because the impacts are huge. I mean, this time, the Moto E is basically chugging its guts out just to keep up the whole time. And I threw the Nexus 7 in. The Nexus 7's very much like the Nexus 5. It's a higher-end quad-core device. It's clocked even higher. But in this case, it's actually loading a slightly different version of the page. So you definitely want to test your tablet version of the page and your mobile version of the pages as well. And then you can load up, sort of the film strip comparison and see what impact that has on the actual visual display to the user as well. So in this case, so the Nexus 5, none of them load nearly as fast as the desktop browser. Gets more of the content up sooner. Nexus 5 still does pretty good. The Moto G and the Moto E both get pushed back pretty heavily. These are what, half a second? Yeah, so these are half a second image. So that adds a whole second to getting the above the fold content to the page just because it's running on a slower device. Same network conditions, same everything else. And the actual on-load time is the same for both of these. It's like literally just getting the content to the screen for the user. Okay. I think this is going to be probably the last piece on mobile. But one of the things that was introduced with Android KitKat, I think, for Chrome was the data reduction proxy. So you can go into your Chrome settings, you can turn on data reduction, and it routes non-secure traffic through some Google servers that basically converts all of the images to WebPs and tries to save you as much of your bandwidth, the end user bandwidth, as you can. And as a site owner, it might be interesting to see how your site's performing when it's going through that mode, depending on how much traffic you're getting through that. And on the server side, you should easily be able to tell how much traffic you're getting through the Google proxies, because they come from well-known IP addresses with well-known headers and stuff. But what you do, let's go to the main WebPagetest. Back in the Chrome-specific settings, there's a enable data reduction. This only works for Android devices. So if you're using the public instance, Dulles has the ones I've been showing you, Moto Gs, Nexus 5, Moto Es, Nexus 7s. And you can test any page going through the data reduction proxy. And one of the things that you'll have to see how representative it is. You'll see a fairly long initial connect time, and that's setting up the SSL negotiation to Chrome's server. That's all done over Speedy, so it's encrypted and everything else. It's only usually done at the beginning of a session, because then once you're browsing, it's already got the connection to the proxy. Unfortunately, every test on WebPagetest is a new test, a new session. So whatever page you test is always going to have this second plus of negotiation time just setting up the proxy connection. Then you can also do like film strip comparisons. What does it look like going through the data reduction proxy and not? And so even with the additional overhead for the second, it looks like in this case, sort of get to one of the film strip waterfall comparisons. If you're comparing more than one film strip to each other, you'll get this little slider up here, or multiple sliders, that lets you overlay and does transparency between the two different waterfalls, so you can see what changed and how well things line up. And it looks like in this case, going directly to the site had a fairly slow first byte time in this case, so it actually happened to line up fairly well with the data reduction proxy test, where the base page in both cases finished at about 3 seconds. But the data reduction proxy version got a lot more stuff to the screen sooner. And then you can go down to the graphs. So down below the waterfall, you get graphs for all of the different tests that you're comparing. The visual progress one basically takes, so beneath each film strip image, there's a estimate on how complete that image is. This just plots it out over time for the two different tests. And then you have graphs for things that are wall clock times, the on-load time, visual complete, that kind of stuff. So in this case, the data reduction proxy actually took longer to get to visual complete, even though it got more stuff on the screen sooner. Although fully loaded and on-load arrived sooner. And then you have both requests and bytes. For some reason, the data reduction proxy was a whole lot more requests, almost double. So maybe it was just timing based that there were a whole lot, and twice as many images. might be worth looking into. But overall, in the number of bytes, it looks like, so total number of bytes, it shaved 30K off, and it looks like it almost all came from images, which is kind of what you'd expect if it's converting all of the JPEGs to WebPs and PNGs to lossless WebPs, for example. So just another thing you can test. Not a whole lot you can do with it. You can file bugs with the Chrome team if you see issues going through the data reduction proxy. It's supposed to be completely innocuous other than changing the image formats. So before we jump into the next section, any questions? Everyone still good? All right. Everyone's still awake. Even better. All right, so data, data, data. I love more data. These are sort of a collection of other things that you can collect when you're running tests. So we sort of already went over the timelines. You can store the response bodies when you run a test. Let's go back up here. And once again, I apologize heavily for the developer version of the UI on this, where everything is a checkbox, and there's no order to it whatsoever. So in the Advanced tab, in the Advanced Settings, it's sort of the anything that didn't belong anywhere else. There's a Save Response Bodies right here. What that'll do is any text / resources or JavaScript resources, so HTML, CSS, JavaScript, it will store the version of the content that was served to the actual browser that was running the test with the test data. So you can see what was the actual HTML that was delivered. What was, when you're looking at the timeline and it says this line of JavaScript at this offset, okay, what was that at that point in time and what did it get served? Or if you're getting ads, what was the ads JavaScript that was actually delivered for the creative that was loaded for the page? So this is a test also of the Guardian. I mentioned that we used to do a lot of testing with desktop Chrome and mobile emulation. In the Chrome tab, there's this Emulate Mobile Browser checkbox, where if you're running a desktop instance of Chrome, you can get it to load the mobile version of a page using a mobile viewport and mobile device scaling and all that kind of stuff. And you might ask, we have real mobile devices, why would we bother doing this? Like I said, the tooling for mobile isn't quite up to where the tooling for desktop is, including the saving of response bodies, for example. So if you want response bodies for a mobile site right now, you have to do it with the desktop Chrome browser in mobile emulation. Hopefully fixing that soon. Pull requests always accepted, just saying. So this is the Guardian, the same page, run in a desktop Chrome browser with mobile emulation. In the waterfall, if you click on any line item in the waterfall, you'll usually get more developer UI, but details about the request. You can get the request headers, the response headers, and the actual response body. So if you have bodies turned on, clicking on the Object tab will give you the content that was served for that request when the test was run. And on the Details tab here, down at the bottom, there's also, because parsing JavaScript in a tiny div on a window is painful, you can load the actual response body in a separate browser tab, copy and paste it out to whatever your favorite editor is, download it, do whatever you want with it. I would say one thing to watch out for, in the case of images, this Object tab, we do not store all of the images that were served at the time the test was run, mostly for space concerns. So this just loads that URL at the point that you're looking at the result. So that may not be the same image that was served at the exact time the test was run. Usually is, but something to be aware of. Oh, and let's see. I spend most of my time when I'm looking at requests in the waterfall, I spend most of my time in this UI. But if you click on the request number link up here, it actually takes you down to a different version of it, where if you want to send someone like the request headers or the response headers, you want to share the URL. When you share that URL, it'll go down to that bookmark, and thanks. Well, this was actually a community patch, so like I said, patches are always welcome. The request will already be opened, and the response, so the request headers, response headers will all be here if you want to show someone, hey, you are closing my HTTP 1.1 connections, you're sending connection close or whatever. Usually do it by sharing one of these URLs that goes directly to the headers, but the response bodies are also linked off from there. Basically links off to the same place. TCP dumps. So this works, as of last week, it works on mobile as well. Also buried in the super helpful advanced settings tab. Capture network packet trace, TCP dump. This becomes really, really helpful to do when you're working with either an ops team or a third party and you're seeing issues. There's always going to be a question, is that a testing artifact or is it real? Usually when you get a TCP dump and you're looking at the packet flows, it's more likely to be real. I won't say I can guarantee it because there's still all sorts of artifacts that can happen depending on your lab environment or your network connectivity out from the lab. But you can say for certainty that no, it wasn't a browser thing. The server really did take this long to respond, or it really did take this long to do something. So when you have the waterfall, there's, once again, I sort of bury all the links off to the left here. If you enable timelines, and we'll get to tracing in a second, and TCP dumps, you're going to have an awful lot of links on the left side of your waterfall. But so the TCP dump links show up on the left side. You can download the raw PCAP, or you can also open it up in CloudShark, which I'm a huge fan of. Let's see if it works. If not, I have one uploaded. Yes. So CloudShark is basically an online version of Wireshark for viewing PCAPs. The main use I have for it, and the reason I love it, is once you view something online, the link to what you're viewing is shareable. So you don't have to send someone a PCAP and say, filter it for this connection or look for this packet. Packet number 34 and 35 are the ones you're looking for. You can go, so in this case, I'm looking, oh great, let me duplicate that and go back to the test results. So here we saw there was this long orange bar was suspicious. It took like 2 seconds. Initial connection, 1450 milliseconds. So 1.5 seconds to connect to the server. Was that a server problem? Was that a problem with the browser? Or if I'm going to be talking to that third party, I need to send them, hey, your server is having problems keeping up with connections. Once again, I recommend doing multiple tests and making sure it wasn't just sort of a one-off problem. If you see it intermittently or happen whatever, capture a packet dump. I usually filter for HTTP first, which will then give you all of the HTTP requests. You can look for, what was this? Nansen Primary School is. Yeah, there's probably a better way to do this, but so I usually just look through all of the URLs and look for the one that I'm looking for. All right, well, rather than have you guys stare at me looking for text, I'll show you how I filter it. So then I end up selecting the request that matches what I was looking for, go up into Analysis Tool and follow this stream, which basically lets you look at that entire socket for the lifetime of the connection. And then I go up here to Show Only the Stream, which changes the filter view in CloudShark, or it does the same thing in Wireshark if you're looking at a packet capture locally. It lets you look back to the beginning of that connection, so you can see the SYN, the SYNAC, the round trip for the actual negotiation. This one wasn't the one with the problem. I think I do have... Yes, I have the one where I actually found the request. And you can see the SYN, which is the browser making the original request out to the server, happens at 8.6 seconds. The SYNAC, which is the server saying, yes, you can connect to me, didn't happen to 10.1 seconds. So yes, it was real. It was not a client problem or an artifact. The server really did take 1.5 seconds to respond. And there were no retransmits on the SYN. One of the things that you want to watch out for, a couple of round numbers that you'll tend to see fairly often. DNS retransmits happen roughly every 2 seconds. So if you see like a DNS time that's slightly over 2 seconds, what happened was the first one got lost, it retransmitted. If you see that regularly, you've got a packet loss problem somewhere. If you see it, once in a blue moon, it's the internet. Shit happens. And yeah, I mean, it's unfortunate. Packet loss rates usually under 1% on the internet at large, give or take 1 to 2% at most. Usually they go completely unnoticed, but if they happen during critical points, they'll show up as multi-second events. DNS is one of those. An initial connection, the socket connection, usually on Windows at least is going to be a multiplier of 3 seconds. After 3 seconds, it does a timeout, and then it retransmits. So if you see socket connect times that are like a multiple of 3 seconds, it was probably a lost SYN packet that was retransmitted. I say usually because Chrome has a workaround where if it doesn't get a connection within 1 second, it races and starts another connection. So it doesn't wait for the 3-second retransmit. It goes ahead and starts another connection and starts racing them against each other in case it was a packet loss to get faster recovery. So on the kinds of things that you will only see in a TCP dump, that's the kind of thing that shows up. So you can see, hey, did it retransmit? Why did it take so long? That kind of thing. And the network guys tend to believe TCP dumps a whole lot better than they believe me. So, Chrome tracing. So this is also a fairly recent addition. If you actually understand the traces, more power to you. They confuse the bejesus out of me. But right below DevTools timeline is a Chrome trace. So if you go into Chrome and go to About Tracing, you can capture a detailed browser trace of what the browser is doing loading the page. And by detailed, I mean it's like the function calls that are going on in the browser while it's trying to process your content. So if you see a performance issue on your page or things that aren't happening the way you expect them to happen and you want to open a Chrome bug, usually the team will come back with, please supply a trace. So this is one way you can get them is you can run a trace and WebPagetest while you're running a test and collect the data. Let's see. So in the test results, can you guess where the trace links show up? Yes, to the left of the film strip. So you can download the trace. It's just a JSON file. Attach it. If you go to crbug.com, that's where you go if you're ever going to file a Chrome bug. And we do recommend please file bugs if you ever see issues. And deduping would be nice, but the team will also take care of deduping if it's something that they're aware of. The other thing that you can do is you can view it online directly. So if you wanted to share a trace with someone, you can share it this way. And it, like the DevTools, I can't guarantee this will work on any browser other than Chrome because it takes the internal Chrome code for displaying a trace and shows it in the UI. We'll give that a second to load while I look. The trace files are fairly large, by the way. Yeah, there it goes. They're on the orders of 20, 30 megabytes. And if you think my UI is convoluted, WASD are your friends. If you play first-person shooters, you're very familiar with those. A and D scrolls left and right. W zooms in, S zooms out. And then the scroll wheel on the mouse is your other best friend. And what you get is a breakdown by the different processes. So Chrome is a multi-process architecture, and it sandboxes like your HTML content in one process. The network stack runs in a separate process. If you have a GPU, the GPU runs in yet another process. and they all sort of talk to each other. And this breaks down by process, by thread. So you can see here's the Chrome I/O thread, for example. And up here are the requests that are being made or that are being scheduled. They don't show up on the network yet. You can see if you click on any one, you can get more detail into what it is. And you can sort of follow things through and see, okay, if it's doing a lot of JavaScript, or if JavaScript's spending a lot of time on something, you can go into the main browser thread and drill into the times, and theoretically you can see within V8 where it's spending its time. Like I said, if you're familiar with it, you're probably working on the browser code, because they're the main ones that understand how that works. But it's super helpful. If you can reproduce an issue with the trace, they can usually get straight to the line of code or the reason that it's happening, and they'll fix the issue a lot sooner. Quick break before we drop over to images. Question in back. So that's Andy. The question was, is there any overhead in turning tracing on? I don't know. You're better off running with and without. I will say that they've done an awful lot of work to make tracing as low overhead as possible. And from what I understand from the team, capturing traces is actually even lower overhead than capturing a timeline because of the amount of work that they've done to make it low overhead. Telemetry, which is the automation tool that the Chrome team uses for doing perf tests, runs tracing for all of the tests that it runs, for example. So it's super low overhead, but it's not zero overhead. I doubt on the order of magnitude of a page load, though, that you're going to see much impact. Like I said, there are 30 to 40 megs a piece, though, so please don't turn on tracing for every test that you run. All right, images, some of my favorite things. More, not necessarily not documented, but not very well exposed. Let's see. Okay, so this case, I ran a test for Engadget.com. Once again, I'm an ex-AOLer, so I have my favorite sites. This one happens to have a lot of images, which is why I use it a lot for image testing. But when you click and you go to a waterfall view, buried down below here, below the waterfall, is a View All Images link. And if you click on that, what it'll do is it will display all of the images in the order that they were loaded on the page so that you can scroll through. Kind of like the images in the waterfall, these are what are currently being served. However, the metadata, the information about them, is accurate for what was done at the time that the test was run. Once again, it's usually accurate, but you can scan through here, you can load, and you can go, hey, that's an interesting avatar. Why is it the first image we load on the page at all? Because it also doesn't show up above the fold anywhere. I think that's one of those, this was the author of the article, and we have no photo of him kind of things. One of the things, I don't see it here with Engadget, but see they've got some nice sprites going on. One of the things that you'll also see when you scroll through here is if you see a whole bunch of small images, you'll go, hey, those should probably be in a sprite somewhere. So it's a really quick way to eyeball all of the images. Well, these are fave icons. I guess a separate interesting question would be why 4 versions of the fave icon got loaded. But even, so there's a little comment about responsive, but responsive should still only load. Well, I guess it depends on how it's implemented and the breakpoints, and yeah. Theoretically, if it's doing like a source set, it should only load 1, but if it's doing, depending on how they've hacked it, it may be loading all versions of it. And the other fun thing is you'll get, hey, there's no image there. All of the things that are tracking beacons that are done as images, whenever you view this page, you're firing off a whole other set of beacons. Just something to be aware of. But you can see, hey, there's an awful lot of images with no content there. The other thing that is really useful in this view is as you're looking through images, it will tell you how large the original image was. And one of the things WebPagetest does when it runs a test for the image, let me see, duplicate. Up here at the top, when it does the grades, there's a compress images. And it'll go through, when it's running the test, it'll take the image that was actually loaded, it'll recompress it at JPEG quality 85, which is like super safe. You should always be able to compress at 85 and not even worry about visual artifacts. And go, hey, was it any smaller? It also strips out all of the metadata while it's doing that. And while it's doing that, it figures out how much it can save by recompressing the images. And it basically gives you an idea of how much savings you left on the table in your JPEGs. It doesn't do lossless image checks right now. But in the case of Engadget, for example, there were 1.1 megs worth of images that really should have only been 620K if they were all compressed correctly. And this view just gives you a list of them. But in the view images view, you can see what the image was, how big it was, and how much smaller it should have been. Like right here, it'll tell you. We can make it a little more visible. So this one would have been 67K smaller, basically half the size if it was compressed at quality 85. And that's generous, right? It could be even smaller compressed at 75. Just so you can see. And then there was a analyzed JPEG. It was also not a progressive JPEG. Like I said, I'm a fan of progressive JPEGs. I'm really looking forward to Tammy Everts has a talk on hopefully finally getting scientific data behind is progressive better or not. So find that on your schedules and attend and go, yes, progressive. Hopefully, if it turns out progressive sucks. Is that 9? 9 tomorrow? Oh, I have 9 minutes left. Okay. I was like, Tammy's talk is at 9. Okay, so I'll step it up a little bit. But when you click on the Analyze JPEG link, it'll show you what the original image looked like. It'll show you what lossless compression did to the image and how much smaller it got. Not a whole lot smaller, 5K. That's stripping out all of the metadata, EXIF tags. Sometimes fun when there's a thumbnail embedded in a thumbnail and you end up with more metadata than you have actual image data. And then what the image looks like at quality 85 and how much smaller it is. So this page gives you a really easy way to see visually what the image would have looked like at quality 85, which is identical to the others and half the size. And it also dumps all of the EXIF data. So in this case, you can see they kind enough for them to tell us that they saved the image in Adobe Photoshop CS6 and some of the history on the image and stuff like that. So that's some of the metadata that you end up seeing in some of these files. And you can see if there was like a copyright that they were trying to preserve or something, but in this case there were no copyright tags, so no reason to have all of that metadata. And one of the other sort of buried in the advanced features is this preserve original user agent string. Usually by default when WebPageTest runs a test, it adds PTST to the end of the user agent string. So your analytics or whatever you're using can filter it out based on user agent string. Sometimes sites will actually break when they have bad user agent string parsing, and you'll want to check that to turn that on. In the AOL case, for example, I guess the ads team got sick of serving ads and counting ads served to test traffic, so they stopped serving ads to the page test user string. So they need to keep the original user agent string if they want to test performance. Resource blocking. In here in the block tab, if you want to do a quick what if, how fast would this page be without JavaScript, for example, is a fairly common one I do, or how fast would this page be without this third party? It's just a substring match, so look at the URL for whatever you're trying to block. One of the things I do fairly often is I just do .js. Anything that happens to have a .js anywhere in it, block it, and see what the page will look like. And this is a fairly easy, I mean, odds are you'll probably break the page. Not many pages work well without their JavaScript, but you can see what impact would you have if you were to spend the time and rearrange how your JavaScript loads. And so in this case, this is CNN loading normally and with the .js blocked. And you can see without the JavaScript, at 1 second, all of the visual content shows up. Huge performance win versus 3.5 seconds normally. Of course, the actual image and ads don't load because we broke the page by breaking the JavaScript. But who needs those? But this is sort of to give you a quantification. Hey, we could actually load our page in 1 second, or at least get the initial experience up there in 1 second if we restructure how we do our JavaScript. The good thing about the resource blocking is it fast fails, so it tells the browser immediately, hey, that resource isn't available, keep going on. SPOF testing, single point of failure, is sort of a different view on that, where this one is only a domain by domain, but you can go in here and you can say, if Facebook was down, not that that ever happens 2 weeks ago, and it happens to everyone, but it's not even necessarily if something goes down, is what if X is not reachable from China, for example? Is my site, what happens to my site if this third-party provider is unavailable? So you can go ahead and put in the domains for that third-party provider. One you'll probably want to test if you use an A/B testing platform, especially a JavaScript-based A/B testing platform, is what happens if the A/B testing platform is unavailable. And then when you run the test, you don't have to do like with and without SPOF. When you run a SPOF test, it'll automatically do a with and without and bring you straight to a film strip comparison. In this case, it's CNN.com with their A/B testing platform, SPOF, and there is no content for 20 seconds. So if the A/B testing platform goes down, CNN is effectively down. No one's going to wait around for 20 seconds for it to load. 20 seconds is one of those other magical numbers that you'll see. That's how long it usually takes for the browser to time out on making a connection to a domain before it gives up. And rather than the fast fail that you see with the blocking, non-responding is very different. Like you saw, 20 seconds. We already went over. The overlay is just the comparison waterfalls with the scrubber. Quick question.
So in the previous slides, you showed the what if simulations.
Yes.
Could you also inject a resource and check?
You cannot inject resources, unfortunately. You can just block what's already there. Sorry. You can go back to the origin site. So I'll talk about scripting really quickly, but I want to get to custom metrics, which is coming up in a second. But rather than testing single-page URLs, you can also test more complex scenarios. You can go to the landing page, then go to the product page. You can go and log into a site. There's a link to the documentation. The main thing to know is you can either combine all of the steps into a sequence with combine steps command, or you can turn on and off data capture and only measure the piece that you're interested in. And then there's a fair number of specific commands for clicking, filling out fields, doing that kind of stuff. The main command you're really going to want is exec, which executes arbitrary JavaScript. Because usually if you're running these web page test specific commands, you get no feedback on why it does or doesn't work. If you're using exec, you can get your JavaScript working in a local DevTools console, get it doing whatever you want it to do, and then just upload that as a sequence of commands that it executes. So like, for example, this is a script to get the weather in Santa Clara, California from weather.com. And it basically goes into the zip code box, types in the zip code, turns on data logging, and submits the form. So also with the scripting, you can modify DNS records to point, like a production site, to point to your dev box, but still use the production site host name. That's a fairly common use. You can insert headers and things like that. Custom browser settings, both Chrome and Firefox. Firefox takes custom prefs. Chrome, you can specify arbitrary command lines. Once again, only if you're really trying to do something really specific. User timing, fairly huge. If you do performance.mark and performance.measure on your page at interesting points in time, you will get timestamps for when those events happened. And that's very useful to use in your RUM performance, for example. If you do those and you instrument your page with those, in WebPagetest, you'll get these purple markers that show up. Like in this case, this is, you can't hover over it, but The second one is when the pie chart shows up in the results page, for example. And so you can validate in the film strip your user timing that you've instrumented in your page versus what the film strip shows to make sure your user metrics that you're getting from the field actually represent what you're trying to measure. And JavaScript start render time, very unreliable, just warn you. But there is, IE has a specific window performance timing MS First Paint, and Chrome has a completely buried in window.chrome.load times first paint time. That'll be exposed in WebPagetest as a light green bar compared to the dark green start render. If they happen to show up near each other, then that's actually a fairly good metric for your site, and it looks like it's representative. Sometimes those lines show up far, far apart from each other, at which point, not so much. So don't trust the start render time in that case. Custom metrics. I know we're out of time, Steve. I'll end on this one. So in the WebPagetest UI, there is a new field over here for custom, where you can insert custom metrics. You can also, in a private instance, you can define these on the server as a collection of JavaScript snippets that go into a folder, and the documentation explains how they work and what they look like. But what that is you can run arbitrary JavaScript at the end of a test and collect anything you want from the page as a metric. So things that were recently added to the HTTP archive, for example, average DOM depth, number of script tags, stuff like that are all done as custom metrics, just JavaScript that runs at the end of a test. The other really useful thing that you can use this for is validating the page content as a criteria for did the test succeed, because the custom metrics can override existing metrics, including the result code. So in the case of like AOL, for example, we can, if we see the copyright at the end of the HTML page, which is what usually we use to signal that we got the page we expected, we can call it a successful load. If we see a copyright tag but not the string we expected, we can give it a different result code. So you can do all sorts of custom validation at the end. You can make sure the stock ticker in the page loaded that like you were expecting it to load and things like that. And with that, unfortunately, I need to run, or Steve's really going to kill me. But I will say in the Chrome booth, we are going, so this whole deck is up on SlideShare. Feel free to go through it. Ask me if you have any questions. There's a book O'Reilly's got coming out. I didn't write it, so you can be sure that the writing is good on using WebPagetest. And in the Google booth, I'm doing a Meet for Speed tomorrow, where we'll basically walk through testing a site. And I also have office hours, but I actually encourage you, just grab me in a hallway if you want to talk about something, if you have any questions.
1 or 2 questions?
Sure, 1 or 2 questions. No, we're good. Thank you, everyone. Oh, right here. Licensing, it's all under a BSD license, which means do whatever the hell you want with it. Don't call me. Don't blame me if it breaks or burns your server. You can take the code, you can build commercial products off of it. Really, there are no restrictions to what you can do with the code.